All right, so this is going to be a video about finding solutions of polynomial equations, and I'm basically going over this concept of finding solutions using 5 example problems here. So hopefully by doing these example problems, it'll make more sense of this concept. So it says, how does the degree of a polynomial relate to its number of linear factors and its number of solutions? So the degree is equal to the number of linear factors. Okay, and its number of solutions, it could be equal to that as well, but you have to include multiplicity, so then it would be equal to that as well. Okay, let's do the next one. It says, find all real and complex solutions of each polynomial. Use these solutions to find the factored form. Okay, so I'm going to write this equation in factored form, but first I need to find the actual solutions. So for number 2, first thing I'm going to do here is I'm going to find the solution. So it's going to be negative b, so it'll be negative 4 plus or minus the square root of b squared, which is 16, minus 4ac, which is 24. And we're going to divide all this by 2a, which in this case is going to be 6. All right, from here, this simplifies to the square root of negative 8. So if you pull that negative out, you end up with the square root of 8i all over 6. Now the square root of 8, there is a perfect square in there, so I'm going to pull that out so we can simplify this further. So if you pull out the square root of 4, which is 2, you end up with 2 root 2 is equal to the square root of 8. It's I still there, and then we're dividing by 6. And we can simplify this by dividing the top and the bottom by 2. So this becomes 3, this becomes 1, this becomes negative 2. And your final answer is going to be negative 2/3 plus or minus root 2i over 3. Okay, and then I'm going to highlight this here. All right, and you should have 2 solutions, which we do because we have the plus or minus version of this solution right here, so that is 2. It ended up having 2 complex solutions, and it said use these to write this in factored form, so I'm going to write this in factored form now. It's just going to be x minus negative 2/3 plus root 2i over 3 times x minus negative 2/3 minus, minus the square root of 2i over 3, okay? Equal to 0 because it doesn't even equal to 0 right there. The one thing that this needs that it's missing right now is that leading coefficient of a 3, so you do have to put a 3 in front of there, otherwise you're just going to end up with an x squared there and it'll be off by a factor of 3. Okay, so that's the factored form of this one. All right, this next one, I have to write it in standard form before simplifying it, so I'm going to do that first. Okay, now that it's in standard form, I can use quadratic formula for it. So it's going to be x is equal to negative 1, which is just going to be positive 1, plus or minus the square root of b squared, which is 1, minus 4ac, which is 40. And we're going to divide all of this by 2a, which is 4. Okay, the negative becomes positive, so you're left with 1 plus or minus. This ends up being negative 39, and you can't take the square root of a negative, so I'm just going to pull the I out. So it's going to be the square root of 39i, and then all of this is divided by 4. Okay, so that's the solutions for this problem. Then we have to do the factored form of it. So it's just going to be x minus the plus version of that. Okay, times x minus the minus version of that. Something like that, all over 4. And I'm going to set this equal to 0 because that's what it was set to in the original. All right, let's go to the next one. Okay, this one's already in standard form. I'm going to set it equal to 0 because I just forgot to do it when I was writing the problem. And you're going to be left with x is equal to negative b, which is going to be positive 4, plus or minus the square root of b squared minus 4ac, which is 16. And this is all going to be divided by 2. Okay. This square root of 0 cancels out, but you still do have two solutions to this. You have 4 plus or minus 0, which ends up being the same thing, but you end up with 2, but because that plus or minus 0, you would have a multiplicity of 2 on this. And another way of looking at this is if you tried to write the factored form for it, you would have to write x minus 2, but you would only have one of them, so you have to square this in order to get the factored form for it. And then we have that one right there. Okay, this next one, it says number 1. The number 1 is a 0 of the polynomial of all that. Write p of x as a product of linear factors. So since we know that 1 is one of the solutions, we can actually do long division and divide this by x minus 1. So that's what I'm going to do really quick. So I'm dividing it by x minus 1. Okay, just looking at the leading terms, you're going to have x squared here, and then you'll have x cubed minus x squared here. And then we're going to divide this, or subtract this all out here. So subtract, subtract. That distributes, you end up with negative 2x squared plus 7x minus 5. Okay. From here, I'm going to multiply by negative 2x, and you'll be left with negative 2x squared plus 2x. Okay, this is going to all change the sign here. This is going to cancel, and you're left with 5x minus 5. And then this is going to be a 5 up here, and then the 5x minus 5 is all going to cancel, and you'll have no remainder. Okay, so that's the other factor there. All right, so now we end up with p of x being factored into the following. So basically now p of x is going to be equal to x minus 1 times that x squared minus 2x plus 5. But this right here, this part right here can be factored as well, because you can see that it's x squared, so that means there should be 2 linear factors in this as well. So what I'm going to do is factor this really quick, and I'm going to use the quadratic formula to factor it. So it's going to be x is equal to negative b, which is negative negative 2, plus or minus the square root of b squared, which is 4, minus 4ac, so it's going to be minus 4 times 1 times 5. So there's a 1 here, here's the 5. Okay. And then I'm dividing all this by 2a, which is just going to be 2 times this 1 right here. And you end up with, let's simplify this out. This is going to be 20. So it's 4 minus 20, which is negative 16. So you're going to be left with 2 plus or minus the square root of negative 16, which is going to be 4i, because the square root of negative 16 is really I times the square root of 16, which is just 4i. So that's where I got the 4i from. And then we're dividing this by 2. Now, if you notice, the top and the bottom are divisible by 2, so I'm going to divide the top and the bottom by 2. And you end up with 1 plus or minus 2i for your solutions for that. Okay, so now we have 2 solutions there, plus that other solution of x equals 1. And it says write p of x as a product of the linear factors. So that's what I'm going to do right here. The p of x in its final factored form is going to be x minus 1, just like we had before here, times x minus 1 plus 2i times x minus 1 minus 2i. Okay, so this right here is the entire factored form for part A. So that's what part A is looking for. So part A. Okay, part B, it says, what are the solutions? Well, since you already have it in factored form, it makes finding the solutions super easy. So the solutions would be 1, because you could set that equal to 0 and solve, it would be 1. It's going to be 1 plus or minus 2i as well, and those are your 3 solutions. And we should only have 3 solutions because it's x to the third. And so it's a video on 5 example problems involving finding solutions of polynomial equations. If you have any questions about any of this video, let me know.